Viewers. So in this video we are going to discuss tree structured directories. Okay. So tree structured directly means we will store all the files in the form of tree. Okay. And each user can form its own subdirectory. Okay. So let's say this spell bin program. Under this spell directory we will make three more directories. One is stat, mail, distance or dist. Okay. After that, in mail directory we are storing any other directory. Okay, so these are the four directories, and under four directories we are storing these all files. Okay, so there are files like stat, distance, which are really a file and contain data, and there are directories also which will make further tree. Okay, or which will contain directories or subdirectories, and in the same way all are being implemented. Okay, and now let's say if any user wants to search list, okay, list file, so in what way it will do is that firstly it will go to programs. Okay, then it will go to p. Okay, after that he will come to know that a list file is stored in this directory. Then it will come here, it will search the whole directory and come to know that this is the directory which he wants. Okay, or this is the file which he wants, and in the same way searching is being done. Now let's take another example. If any user wants to delete this all file, so in what way it will go? Firstly he will go to spell, then mail. Okay, so firstly spell, then mail, then he will come to know that all is stored in copy. After copy it will come to know that this all is stored in copy, and it will delete this file from here. Okay, so now copy will be empty. In this way deletion is being done in tree structured directories. Okay, in tree structured directories the upper one are nodes, or means parent nodes, and the down directories, you can say downward nodes, are known as child nodes. Okay, so firstly all the child nodes should be removed from any directory, then only that directory can be removed. Okay, so let's say this copy directory should not be directly removed. Okay, firstly we have to remove this all file. Okay, this file should be removed from this directory. Only after that we can remove this copy directory. Okay, so firstly all the contents of a directory should be removed, only then we can delete any directory. Okay, so let's move on to acyclic graph directories. Here these are just similar to tree directories. Okay, tree structured directories. The thing is that we can share the files between different directories. Okay, if we want to save any file in the directory, let's say we have one count directory and we are storing one file A. Okay, and the same file we also, any other user stores it in count here. Okay, in spell of count. Okay, so what is happening is that it is using redundant memory, or it is allocating extra memory. So what we can do is that we can just directly give the reference to that file. Okay, so this is the reference we are giving, and in this way sharing between the directories are being done. Okay, so let's say this is the file which is being shared between two different directories. Okay, these two different directories are not same. Okay, this count and this count is not same, it is under different directory. One is being under dict, the other one is under spell. Okay, so and it will be sharing the directory. In the same way list is also being shared between words and w. Okay, and in the same way the contents of list are being shared by all. Okay, so while deletion, so the deletion will be quite complicated than in the case of tree structured directory. Okay, here if we want to delete any node, what we will do is that we will just remove the reference of the directory. Okay, if we want to delete list, okay, list, this is the file which is being stored in w and words also. But if user 1, let's say this is the directory of user 1, and if he wants to delete this list file, then if it will delete the list file from here, then the user2 will sit as vacant? No. What it will do is that it will just remove the reference of this file, and user2 identity will be made or will be remain as it is in the list file. Okay, so what I'm saying is that if user2 and user1 both are making one list file, okay, and any one user wants to delete, then it should not be reflect for user2 also, okay, or any or the other user also. He will directly remove the reference of the file from its own directory, okay, and that file will be erased from its own directory. So if we remove this link from here, okay, from this subdirectory, if we remove the link of the list, then you can see that there is no way we can reach list. Okay, so this is the concept of acyclic graph directories. The other is general graph structure. Okay, so in general graph structure, we need to keep account of that we should not have any loop in our structure. Okay, if there is any loop in our structure, means a loop of references, then what will happen is that if we are searching, okay, let's say if we are searching from here, okay, and if there is any loop, okay, from here, then what will happen, it will come here and then again it will go here and it will search, and because of this performance will degrade. Okay, so let's say there is one file 1, this is second directory, this is third directory, this is fourth directory. So if there is a loop, then it will come like 1 2 4 3 then again 4, and it will search the file in this loop, and the searching will always stuck in that loop and the performance degrades. So this should not be happening in the case of directory structure. For that we have to make or we have to deploy the algorithm for that performance should not be degraded because of searching in loop. So if cycles are allowed to exist in directory, we have to avoid searching any component twice. Okay, so if 4 is means visited once, okay, then we will keep account or make it the flag 1. Okay, so after 0 we will make the flag 1 and it will not visit again, means the searching function will not visit the 4 again. So in this way algorithms are being implemented, and a poorly designed algorithm might stuck in infinite loop. Okay, so we have to keep rid of this. So in next video we will discuss file system mounting. Okay, and the slides which I am using in this video you can access from the last video of this module. Okay, so till then, thank you.